Oh, okay. We're having a little problems here for a minute, but the agenda today is going to talk about really RUSLE2, the overview, a little history of the tool, RUSLE2 2.5.211 that was released last year. The date of release is August 18, 2014. And again, we're talking about some of the basic input variables that goes into RUSLE2 to get a legitimate computation. Crop management factor and facilitating practices. We're going to look at soil disturbance, residue management standards 329 and 345, and really how they are applicable and for use in RUSLE2, and really how we can use RUSLE2 to meet the standard criteria for 329 and 345. Concentrate a little bit on the soil conditioning index. The soil conditioning index and the soil tillage intensity rating has been around for quite some time now, so I think all of us may be familiar with those output variables that come out of RUSLE2. And then talking with some of the TSPs when we did the traveling show around the state, they were struggling with sometimes SNAP Plus not having all the tillage tools that RUSLE2 has. And so we'll look at the major tillage types that we have built in RUSLE2. And so as stated before, if you have any questions, just ask as we go. Well, the revised universal soil loss equation, if you think about the history of the tool, for those who have been around for some time, we had USLE, the universal soil loss equation, then we went to RUSLE. And both USLE and RUSLE, we use tables and charts, and it was a struggle at times to get a computation, okay? But one of the major things with RUSLE2 is that the information that we put in has to be good information in order for us to get a valid computation. And keep in mind that with RUSLE2, and that can be problematic at times, is that we're only looking at one slope grade and one slope length. So if we want a combination of computations, we would have to get a combination of different areas within the conservation planning unit to determine soil loss, perhaps on a C slope or a B phase or even a D or E phase. And so USLE was first published in about 1965. Many of you may have the handbook 282. I do have it here. And then we had an update in 1978, handbook 537. Okay. Now, when you think about RUSLE, USLE, the research data, the number of research years that went into developing the tool is very important. And the reasons why I say that is because this tool, RUSLE2, can be used anywhere in the nation, anywhere in the world, if we have the databases necessary, such as soils and such as climate, to get a computation. And actually, the tool is used around the world. And so what does the tool do for me? Well, it can give you an average annual soil loss, soil conditioning index. We'll talk about that in a little more detail, a stir factor, and we also have the energy calculator that can be used. One of the more important things that we're concerned with as it deals with compliance, it deals with NR 151, the agricultural prohibitions for runoff, whether it is NR243 for CAFOs. This is the tool that we can use to determine if an individual client producer is compliant with state law. And again, as I stated in talking with Judy Derricks, what we thought we should do is start with the basics, okay? So the RUSLE2 factors that are involved, well, A is in tons per acre per year. We have the rainfall factor, in which, based on rainfall intensity, the amount of rainfall we get per year. However, it does not deal with snow melt, okay? However, within RUSLE2, probably in the science model, we can look at some information regarding runoff in terms of snow melt, okay? Not used very often. Now we have K, the soil erodibility factor, which is very sensitive to erosion for Wisconsin. We have a majority of silt loams. That's a dominant texture that we have in the state. And so K, the soil erodibility factor, really plays a major part in the erosion rates that occur. Also the slope length, slope steepness, and what else is important is the crop management factor, the C factor. You know, with the RUSLE2 now, quite often sometimes we don't focus on the C management or cover management factor, which deals with the residue, it deals with the crop being grown, yield, and so on. And then we have the supporting practices. As we advance in this series, we will be looking at how to design a terrace using RUSLE2 in terms of soil loss calculations using a terrace system, how to use the contour buffer strip, how to use the strip cropping system in RUSLE2. So as we advance, and I think that's scheduled for series number 4, okay? So RUSLE2 only calculates what we refer to as sheet and rill erosion, which is really just a thin layer, very thin. Let's look at the thickness of a silver dime of soil movement from the upland part of the slope to the bottom part of the slope where the soil deposits. Now, when you think about in terms of 5 tons per acre per year, that's about the thickness of a silver dime per acre, okay? Just to give you some insight on what that number actually means. So why do we care about RUSLE2? Well, I stated earlier that we use it for compliance, Food Security Act of 1985, and we can, and our partners and TSPs can use it to determine if someone is compliant with state laws. We use it for sod busting purposes. In terms of state regulations, I indicated 243. The Wisconsin Pollution Discharge Elimination System permits is required, ATCP 50, and then NR 151. One of the things too, dealing with producers and when they request assistance from us, we can use the tool to help guide management decisions that they do make. Some of the important things dealing with RUSLE2 that one of the things that I failed to show planners is the leaching index, which is a component of RUSLE2. And the reasons why I decided not to use it in terms of leaching of N is because it's not responsive to management. And so looking at the soils, We look at how much precipitation we get over the year, how much irrigation is occurring, the soil texture, and we can get a leaching index. But the only reason why I didn't show it very much in terms of a guide for management decisions for producers, it's just not responsive to management. Very soon, according to Jorge Delgado, I should be receiving the nitrogen leaching index that we have calibrated for use in Wisconsin. It is responsive to management. So whether you throw urea on the surface or incorporate it, it's going to be responsive to that type of management activity. Getting back to RUSLE2, the objectives of the farm operation, we would inventory, evaluate the impacts of erosion, and then determine if we have a resource problem or not. Very familiar slide that we have here. We see this all the time, but there's some issues relating to this conservation treatment units, which we see ephemeral erosion. We also see rills occurring and sheet erosion. However, just as a side note, I think we all know that RUSLE2 does not calculate erosion as a result of concentrated flow or gully erosion. Okay? It does not. It just focuses on sheet and rill erosion. This is an example of some shallow flow. I think this site here, water depth was probably somewhere in the neighborhood of about a foot on the upper banks of the flow channel. But again, RUSLE2 does not calculate erosion from concentrated flow situation. The next variable within the universal soil loss equation is the crop management factor that deals with crop rotation, types of tillage practices, application of materials such as mulch and manure, the removal of the material, corn stover, and then random roughness in the field. So all this is related to what we refer to as the C factor. Here's another example of canopy cover, how residue not showing up, but how residue will protect the ground surface. Here's an example of random roughness in which the soil is protected from the energy of the raindrop. I don't know why that's not working. Is that because it's in PowerPoint? Oh, maybe because it's in PowerPoint. Okay. All right, excuse me. What's going on? We're just having a few problems on moving from one screen to the next, so be patient. Oh, there it is. I wonder what happened. In terms of supporting practices, contour strip cropping, contouring terracing, contour buffer strip. All things being equal, which of the supporting practices you think will result in a greater reduction in soil loss? Any thoughts? It actually would be the contour strip cropping in most cases. It's either a combination of the contour strip cropping or the terraces. It depends on landscape position, and but again, I said all things being equal, contour strip cropping would have the greatest reduction in soil loss. Here's an example of a slide showing someone on the contour. As a side note, that really the effectiveness of contouring or cross-sloping is really increased when slopes are between 4 and 10%. So anything less than 4%, you don't really have a big advantage in terms of reduction in soil loss. The consolidation factor built in RUSLE2 is when soil becomes aggregated or consolidated with no till for at least 7 years. So after 7 years, RUSLE2 inserts the variable consolidated soil, meaning that that's the maximum amount of aggregation that we can occur within the tool. So for example, if someone has continuous no-till greater than 7 years and they were to till the following year, okay, the erosion would be less as compared to someone who has continuous tillage. Okay, same crop, same yield, and that's because the soil has been consolidated for over 7 years. So even though the rotation would be the same, even 2 years down the road, a field that had been no-till for 7 years will have less erosion than one that was tilled prior to. Just very briefly, talk about the NRCS tillage standard, no-till, strip-till 329. Within the standard, we have a stir value of less than 10, okay, in order to meet no-till. Now, RUSLE2 will also tell you if your stir value is over 10 or below 10, and the other criteria would be no more than 15% of the surface area disturbed, okay? Now, in terms of strip-till, greater than 10 or between 10 and 15, and no more than 30% of the surface area can be disturbed. Now, in the mulch-till system, we have full width tillage. However, in order to meet the mulch-till standard, you need to have a average stir of less than 80. I don't have it in the slide here, but less than 80 or less to meet the mulch-till. So really, it's not really all about the residue, but it's about soil disturbance more so. This is an example of a vertical tillage tool, a soil conditioning seedbed conditioner with a coulter caddy, rotary harrow, and rolling basket. And the reasons why I show this tool is because myself and Laura Good inserted 2 tools to be used in Snap Plus. Okay. This is a Salford vertical tillage tool, but it has angles, coil tine harrow, and a rolling basket. Now, these 2 tools has been embedded into Snap Plus. What I would like to do is show you something that comes out of the operation file for that tool. Okay. So sometimes when we try to model a tillage tool, we try to do it to the best of our abilities if it's not in RUSLE2. However, if you look here, I don't know why that's not working. But what I was showing here is the operation stir is 20 for that tool. Okay. If you look at the processes here, so what RUSLE2 is telling us that if you use that tool on a growing crop, it's going to kill the vegetation. Okay. What you do? apologize. Oh, there it is. It must be over here somewhere. We're having trouble just going from one slide to the next, okay?
Right here.
Oh, right there. Okay. All right. Okay. So I just wanted to show you the example of how you use these combination tools. Within RUSLE2, we have the Culture Caddy, which has a stir of 3.4. That type of tillage tool, and I will show you another slide in a few minutes talking about what type of tillage type is that tool. And the Culture Caddy is considered mixing with some inversion. Now, if you go down to the bottom here, yeah, there it is. If you go to the bottom of the screen, you see surface area disturbed. That is 100%. So the use of the Culture Caddy will not meet the no-till criteria. Here's the rotary harrow. It has a stir of 10, okay? And that tool is primarily, tillage type is compression. And then the rolling basket has a stir value of 6.8. And it is considered compression tool, and the surface area disturbed is 100. The purpose of this slide here, some of the discussions that we had around the state was, you know, why would a field cultivator with 6 to 12 inch sweeps show less erosion than perhaps a vertical tillage tool? But one of the things that we're going to do in the next training is drill into a RUSLE2 run and determine what happened as to why the standing mass sum, pounds per acre, was reduced from 1,500 pounds to 940. Okay, you see that? And then why was the mass in terms of pounds per acre in contact with the surface went from 4,600 pounds to 5,000. And so if we look at the net surface residue here, we increase by 2%. And so when we look at RUSLE2, those are some important variables that we have to consider. Here's another example of a seedbed conditioner, a Culture Caddy with a rotary harrow and a rolling basket. Now, okay, so in the spring, the operator used this tool before planting the soybeans. And so we had a standing mass of about 1,700, okay, pounds. And then after that tillage tool pass, we went from 47 to 200, okay? So evidently there must have been some burial of residue more so. And we went from 83 to 80% surface residue. Another thing that impacts the erosion too, if you look over here, is the roughness. We went from 0.24 to 0.39. And the roughness has a very profound impact on erosion, because the roughness really serves as valleys, and it can serve as mini dams that trap the water. I wanted to show you this slide. We talked about it before, but tillage types in RUSLE2, okay? Inversion plus some mixing. We have mixing with some inversion. We have mixing only, lifting and fracturing, which could be some of the manure injection tools. And then as we talked about the compression tools, we looked at the rolling basket here, okay? And then the burial pattern tells you how much is buried based on the tillage depth. And then we look in this column here is the distribution of that residue, okay? Here's a good example of soil loss, vertical tillage system versus a strip till. And if you look here, the corn, soybeans, no-till, 15-inch spacing on the soybeans. The soil type with a C-phase, silt loam, 9% at 180 feet, and here's my yield. But look at the comparison versus no-till versus use of the vertical tillage tool. And the vertical tillage tool was the implement that we looked at before, which consisted of the coulter caddy with the rotary harrow and the rolling basket. And you can see the difference in soil loss, okay? One of the outputs that we can get from RUSLE2 is the SCI. The SCI is really qualitative. It's not quantitative. But what it's going to do is give you a negative value, which means that we're trending down on organic matter, versus if we have a 0, meaning that we are not going to have any change, then versus a positive number, meaning that we're trending upward in organic matter. Just as a side note, whenever you have a number that goes from -2 to +2, that's where the tool is most accurate, according to the database managers. Okay, so again, it's an indication of what we expect to have for organic matter, whether we are trending up or trending down. For the cover crop standard and using the cover crop as a resource to address a resource concern, we have to look at what are the conditions of, in terms of the SCI, whether we are increasing or not, if we're solving the resource concerns. Usually we put that cover crop in for erosion control, but it can also be used for increasing organic matter. Okay. So it can be used as a tool to measure if we have excellent soil quality or if we're improving soil quality. As a matter of fact, the SCI is an indicator in the Wisconsin planning criteria that is in our EFOTG, section 3, that tells us whether or not we have a resource concern when it comes to soil quality and organic matter. But keep in mind that if we're not changing the soil conditioning index using RUSLE2, what we can do is go to the water quality criteria. And if we have a reduction in what we refer to as sediment delivery to the environmentally sensitive area, then we are addressing a resource concern. Okay? Sometimes when we use the cover crop, we may not see a change in the SCI. I just wanted to bring that out. Okay. So we have the residue portion, or the organic material. We have the field operation that we're looking at, and we have the, the erosion component. So if you are not doing very much soil disturbance, okay, you have a high residue producing crop, and your erosion is very low, well, you're going to have an increase in SCI. The next tool or variable output from RUSLE2 is the STIR. The STIR value is the tillage intensity rating, which goes from 0 to 200, and it measures the amount of disturbance in terms of the tillage type that we looked at before, the surface area disturbance, how deep we are with the tillage tool, and really how much are we breaking up soil consolidation. Okay. I threw this slide in because one of the issues that we have noticed too, perhaps in times past, is why is there a discrepancy between RUSLE2 and SNAP Plus? Well, there really is no discrepancy. It's only when we put in the incorrect input values, okay? So do we capture all the tillage and soil disturbing activities? Did we ensure that perhaps a residue was not removed after the operation or operation dates? Did we use a cover crop in the rotation? One of the other problems too that we find that when we are comparing RUSLE2 and SNAP Plus and we have discrepancies is the manure consistency and method of application. And another major issue is vegetation types and yields. Now, if you look here for practices, remember that RUSLE2 allows a lot of flexibility in terms of where we can put a contour buffer strip, that we can take credit for cross sloping, in terms of perhaps placing a filter strip in the upper reaches of the landscape, perhaps on that planting slope. And so RUSLE2 is a lot more flexible in terms of being able to more accurately calculate the soil loss when we have a tendency to deviate from true contouring or other variables that are in SNAP Plus. So in this case, everything being equal, normally we will come out with the same number in terms of soil loss. And so really, the take-home point is that slopes makes a difference. Soil disturbance is very important. We have to consider the practices, supporting practices that we use. And just as a side note, RUSLE2 should be based on field verification, okay? That's what it should be based on, field verification. I just wanted to just briefly tell you that the next series, we're going to look at RUSLE2 2.5.2.11. That's the version dated August 18, 2014. We're going to look at the profile template. We're going to look at how to model tillage tools for use in RUSLE2 when they do not exist, and then downloading and creating databases. Do you have any questions at this time? What I would like to do is just show you, we have a guidance document that's going to be coming out today. And it was primarily for those who have not updated their RUSLE2 database, created for not only our NRCS field staff, but also the TSP. And so I would like to perhaps go there, and I would like to show you a combination of themes. Of tools that we, guidance documents that we do have available, okay? Again, these are some documents that could be of use to you. What I am going to do is open up this RUSLE2 data dump. And so this can be used without really drilling into RUSLE2 to see what the stirred values are. If you look at that column, I have all operations that were pulled out of RUSLE2, and you can look at all the tillage tools, okay? So I'm just going to pull this tillage tool right here, okay? Number 51, line 51. Chisel plow disc twisted points, and it has a stir of 65. Column G really gives you a nice write-up of the tool so that you can verify that the tool selected is actually the right one, okay? I am going to close out of that. That's going to be available, and it will be available in section 3. conservation management systems. Also, what will be available is a webinar, a PowerPoint that was held, webinar put together by myself and Laura Good in 2014, really in detail discussing the issues that we may have or the conflicts we may have when we look at the revised universal soil loss equation and SNAP Plus. What you will notice is that the data that you see is a reflection of the last version of 1.26 RUSLE2, okay? And so for informational purposes, that will be available also. In our next series, what I will be showing you is how to really look at erosion at critical periods of time, okay? And so we may have a rotation that's very close, and we may say, well, I can't see why I have so much soil loss on this run versus the next run. Well, we can actually look into RUSLE2 and graph erosion on a daily basis to see why I have erosion at this period of time versus perhaps the run that we are comparing it to, okay? And we are going to do that on the next series. We have also the NRCS planning document. All of you are familiar with this document on selecting the slope, the most restrictive slope. I would like to say that as we discuss the critical planning area that we're looking at, is that if we have a planning unit and we have a environmental sensitive area that's greater than 700 feet from the water source, we may need to consider the erosion rates that are contiguous to the stream. And so we may have to have more detailed planning next to the stream versus being 700 feet away from the environmentally sensitive area. Here is a map showing the CMZ1 and CMZ4 boundaries, okay? Also, as indicated, I'm going to go quickly to the site, and I'm going to show you where the databases are. I'm going to send out the directions today along with a bulletin indicating where those are located and really how you can update your own RUSLE2 database very quickly because they have been pre-built, okay? And it's going to provide you with the file structure. So now what I'm going to do is I am going to go to the home page. I don't see my home page. Bear with me. Okay. Okay. What I would like to do is go to the Fields Office Technical Guide. I am going to drill into section 2. Okay. Drill into RUSLE2. And I have it split out by area, northeast, northwest, southwest, and southeast. I'm going to click on the northeast. This is how the databases are built. For your County Pacific RUSLE2 database, every county that's contiguous to you will have the soil information and the climate information that you can make a RUSLE2 run. Okay? Just to clarify. So some county-specific databases may consist of CMV4 and CMV1, and every county contiguous to the main county, working county. I just wanted to let you know, but these have been updated, okay? Updated with the soils and updated with the most recent CMV. Now the web database MDBs are not there yet, okay? And I think Charlie may have time to put them on today. I'm not quite sure, but the document that's going to come out is going to tell you how to put those documents into on your C drive, okay? And so I didn't know if you have any questions, if anything else you want to talk about, but I believe that it's going to be next week, probably early next week, we're going to move to series number 2, okay? I'd just like to ask a quick question for our NRCS staff or TSPs. Do you have the WEPS program loaded yet on your computer? That must mean no. Okay. I will provide some information to you on how to make that available. But very briefly, I'm going to go to all programs, USDA application, and I'm going to click on WEPS, and you should, if you have WEPS loaded, this is where it's going to be, okay? If you need help, and if you do not have it loaded, you have to have your assigned IT person to load it. And then if you need help from that point on, I am available, okay? And so that's the end of our presentation. I apologize. Not that it was a dumbed-down version for those in their infancy in terms of planning, but myself and Judy Derrick figured that, hey, let's start at ground, then move up, okay, in terms of complexity. So do you have any questions? What I would like to know, if you want to send an email of what additional training you would like to see for RUSLE2, okay? Just send your comments in, and then we will seriously consider them and put them into the training session, okay? So if not, I appreciate your time. Appreciate your time, Penny, for helping us out with the webinar, and Charlie. Okay. Thanks for everything.
Thank you, everyone, for participating, and thanks, Terry, for your presentation. And I just wanted to mention that we're kind of offering this through the SITCOM, the State Interagency Training Committee is part of offering this program too. So thanks for joining us, and have a good day.